So please bring your own research questions and
Yeah,
research
we
interests.
can guide you guys. Otherwise, you can develop you guys' own customized tool. This is a really good chance.
Yeah. Oh, yes, we have here. Yeah.
You made it.
Yeah, it's almost done.
Yeah.
So, like here, it's the logic is all same. So this is, I built the too small here. So let's say 5. 5. See. Yeah, so the logic is the same. Like we have a network, which is the circulation pattern in the building, and we have a number of rooms or number of people in this building, you can say, and we have a destination which could be the exit, but it should be on ground because we wanna calculate the whole building network system. And then the result is showing that this is the result. So here is the stairs. So of course, the stairs along the stairs, it will have a more between index value, which means that more people pass by on this point. And then you can check the actual number of visits for each edge. For example, here, like around 270 people just passed by here, and here is 423. Let's look at here. Here the exit is like 750, and let's go here. Like yeah, the edge here is a 27. Yeah, you can quickly check the how many people pass by if you design the circulation for the building like this, and you can also see this betweenness index by using this. Again, the betweenness index is not directly reflect the actual, just the absolute number of uh, visits for each edge, but it should be related. But you can compare it, and maybe you just redesign the circulation network in a building, and then you just reevaluate it. You know, this is a very quick process. You know, you just need the building network component and this network analysis component and between this analysis component, and that's it. You know, just with the three kind of phases, you can quickly examine the circulation, the pattern with your design, in indoor design, right? So yeah, this is that's it. I will upload this building file, or maybe you just redesign this indoor network, and then you can you can design your building in network. So okay, NJ will take the.
Okay, great. Do you guys can see my screen? Yeah, I can see you guys' face like a little.
Maybe we have to take like 5 minutes break. I don't know.
It's okay. Just stretch your body a little bit. Yeah. Just like this. And then we can do one more extra.
We've got some questions on the chatting.
Okay.
Yeah.
Oh, yeah, we can count the total number of pedestrians. You mean for the betweenness analysis, or like you want to know about the total number of visits? Yeah, you can do that. You can just simply sum up the destination points value. Yeah, that's it actually.
Okay, great. You know what? I have been utilized the graph network system around 8 years as a designer or computation designer, software engineer. But I think once I work with the NJ&Woo, I realized the importance of the number. I think I'm just focusing on the network analysis for the software or developing some algorithm things. But I think understanding the meaning of a number is really important. So I guess you guys have a really good chance to understand what number stands for. Not only that, but also we know the history and the some of algorithm or mathematical equation behind the scene. I think this is the beauty of her lecture toward the network analysis. I think. Thank you for your time. And also, really quickly, I'm drop by individual component with a little bit different aspect. So she described the components from the network analysis, like a researcher or and a designer perspective, but I'm just going to describe what the component does really quickly. And then I'm going to give you guys like some homework and little extra study material at the end of this workshop, okay? Great. So let me rearrange the window a little bit. Okay. So as you can see, if you press Control Alt and mouse left button on top of this icon, you guys can see where this come from, right? So this component is more about like, let's say, modify the line before create the networks. So actually, I can really quickly draw some idea what happening behind the scene. So we have, okay, let me move this a little bit here. We have, let's say, 4 distinctive process behind the scene. The first one is we need a line to build a network. But some line is a very perfect line. Also, but some line has some, the gap between the node that need to be close to each other. Also, in case that you have a multiple polyline, so we need to clean up this line. So we're gonna talk about how we clean this one using some of our icon. And once we have this kind of the line, the network gonna be built individual node and edge on top of this connectivity out of the line, right? So now we have like a perfect, like a network like this, and node, individual node, and the line is edge between nodes, okay? And then what we need to do is we have a origin point here, right? And destination here, right? So once we designate origin point and then this the destination, so we do some of like for the propagation. So we basically calculate the individual lines, the distance, yeah. And then once we've done for the propagation, throughout the backward propagation, we're gonna find the path based on the calculation. So I'm gonna describe it later, the day after tomorrow. But I'm just wanted to mention in order to make some of the mental structure of the network system. So here, if you have line like this, we have a like sort of a random line. We can basically designate the resolution of the networks. So for example, if you wanted to build like 1 meter network, but don't try to do this because it's gonna make a really heavy computational operations. So basically we decompose individual line as based on the number that you designate for the resolution. So basically we like tessellate the line based on the resolution things. And also in case that the line has little space and gap between them, because in case that you download the GIS file from ArcGIS shapefile or what is this? I couldn't remember the name. The OpenStreetMap, things like that. We need to clean the network before building a network. So this component is help us to join the individual the node based on the tolerance, and also there's a types of how we interpolate, how we join the gap between the nodes. So I just prepare some algorithm for you guys. So this is also extra things. And also we have this kind of random polyline. Actually, this is polyline, but the polyline, we couldn't build the network out of a polyline. So we need to tessellate, we need to trim them as a line entity. So I think this component does decompose polyline into multiple lines, which is very useful for you guys. So as you can see, we can index. So as you can see, polyline decompose as multiple lines here. And also, I mean, the point from the GIS file, as I said, this is very dirty. So sometimes a lot of point is located in the same place that breaks your component basically, because think about like, one position has 1,000 of line at the points, and then the network system gonna try to build 1,000 of network inside of the system. So it's no good for building the network. Okay, yeah. So you mean like this? Flame through, bifocal. What does it mean bifocal? I have no idea. Could you tell me? How can I see what is bifocal? I'm not the grasshopper geek, so plug in the automatically show component name. Okay, I think just draw out here, right? Is what you want?
I think so. Yeah. They want to see the name of component. Yeah.
So we gonna reduce the name. Yeah, I'm sorry. Because I used to see the icon. Ooh, they have become fat. Okay, we can make it like this. Okay, so this is the shortest path example here. So this basic analysis tool is really focusing on based on the theme that Jung-hyun taught us, okay? But this component is a little bit like a tweaked, and then, I mean, basically we can develop our own custom tool on top of this idea, but that one has a little bit different like a perspective, okay? So I decomposed the polyline into multiple line using this component. And then this is the divide. So meaning that I divided this line within the 15-meter resolution network. And then I inject this network to this fat component here, yeah. And then I simply inject the origin. This is origin, starting from origin. And then this is the destination, yeah. So we have here simple origin here and destination here. And then the component is gonna be generate the shortest path. So you can click this one. Oh, by the way, I couldn't see any result. Do you know why? Because we need to execute. Once we execute, you can turn off so that you can freely move. Turn on. You can freely move the origin point and then destination. Yeah, I think it's good for us to just turn on the icon. Yeah. And then maybe you can do this. Yeah, I think this is the better. Yeah. So also it has a special component. Let's say print here, print network. So what it does is just decompose network as a strings, so that we are able to save this network as a CSV file here. Yeah. So after that, once you save this network, you can actually rebuild the network out of the CSV file that you saved before. This is the idea behind the scene. And so yeah, I think that that's it for the simple shortest path here. And then we have a same Cambridge area, and then we have this many origin point here. Crazy, right? Do you know how many? Around 7,300. And then we have one single, destination here, right? And then it automatically calculated. So let's see the component, the first component. So this is the visualization component here. So same as the basic tool, we can see all the legend, and then we have an index here. So these are parameters that you can inspect. Basically, you can save this data. You can compare this data later. So this is the network score here, and then we can look through all the data that out of this result. Yeah. Again, the research topic is important. Once we set up the research topic, we're gonna tweak the network, and then we're gonna give you guys which data we need to understand and then tweak them. Okay. Also, we have the enumerator here, so you can simply use either the slider or this enumerator. And then not only that, also we have some like a tapering visualization things here, and then some value for the offset for your visualization. So this component is basically visualizing the network itself after calculation. And then this one is the visualizing the path. Yeah. So if you press Ctrl Alt left mouse button, this is the here visualization path. You can simply hook the network to here. Yeah, this is actually the network here. Okay. So, but it has a minimum and maximum value, so that based on the maximum value, we can basically sort the line. So here, I want to see, let's say after 700 and 1 kilometer. So we are using the meter system in this component right now. So these are all the paths within this distance. Also, you can do like a minimum 0 to, let's say, walkable distance like 500, for example. So you can basically sort the line. Actually, this icon is confusing me. Yeah. Let me change this one. Okay. So what I did is I'm trying to visualizing the line based on this network distance. So what I did is I inject network distance as an index, right? So this one's not only give us the path, but also give us the number, so which is network distance here, okay? And then I just use this value for extrusion, the line. I mean, there's a lot of way to, if you guys grasshopper professional, so there's a lot of way to visualizing, by the way. And we have the network inspection tool. It has nothing to do with visualization, but for those who interested in looking at the number, just as Jonghyun mentioned, so if you guys want to use the TensorFlow or scikit-learn or R, we need to save this data as a CSV or whatever form to load in that statistic software. So this is the inspection for the network. So we have multiple, the data that you wanted to inspect. And then I just make a simple like visualization. So we have this component what it does is, I don't know whether you guys are familiar with the normalize or not, but normalize is basically normalized data range. Whatever number, minimum, maximum, doesn't care. It just fit inside of the one, between the 1 and number 0 and number 1. Yeah. So that we are able to convert this normalized value to the false color, and then we can visualize it. So as you can see, this is a very deterministic calculation based on the distance, so that we can see that result. And describe it. This is actually a concept from the pandas library in the Python. So we basically implement the same function for those who wanted to see quickly the statistical report from the entire number list here. So now we are inspecting the network, right? So narrow down to the area. So this is the area, right? So meaning that we need to designate some particular area, and then we want to focus on, inspect the node inside of this designated area here. One more narrow down. We have a 1 point here, right? And then this point is actually, let's say this point give us some inspection here. You can just simply dragging. Okay, let me see the network. While you're dragging, you quickly inspect the individual node, and then give us the number. So, I mean, this is one of the possible scenario that you can take advantage of this component. So now we have like 7,000 origin point and then 1 destination. And then meaning that 7,000 agent looking for the shortest path from their origin to the destination. And we have like a very, we have a lot of the origin point. So in this context, this inspections help us to focus on particular node that we want to inspect. So for example, you want to build some building around this site, or you want to build some cafe or restaurant around this area. So you guys can see by using inspection node component here. And then we have the same Cambridge area here, and then 1 origin point, destination, nothing special, I think. But what it does is it gives us multiple paths, not just for, let's say, the shortest path. It gives us like a multiple candidate of the path with some destination, the length of the distance, basically. So we can give us some sort of range to parse the network. Yeah, like this. Yeah. So the idea behind the scene is that we do multiple iteration. In this component, we do 61 iteration. And then if they has a similar path, we just skip it. Otherwise, we can keep learning in order to generate the other, let's say, possibility, so that we are able to get this kind of line. So this is the other visualization. This is pretty big. Yeah. So here, okay, I'm losing some parameter. I put the 10000 because I wanted to minimize the extrusion here, like this. Okay. Yeah, like this. So we can just visualize the path, and then the extrusion belongs to the length of this path. Yeah. Then this is the interesting network for those who have a question about how we assign the weight. So I'm going to focus on this network here. Same as before, we have an origin and destination. Yeah, like this. But we have 3 different destinations, like Harbour Square and Kendall Station, and what is this? Kendall Station. Yeah, this is Kendall Station. This is Central Station. Okay, so what I wanted to visualizing is the attraction. So let me visualize the distance. Yeah. So because the cold color represents like a low number, and then the one color, like a lead color, representing the high number. I think that this is very deterministic. You guys can expect it without the simulation, right? Because it's based on the 3 designate point, and then we have only one, let's say, origin point here, right? So if I generate the shortest path is like this. It makes a lot of sense, right? So this is actually what we did, right? However, this component is special, as I mentioned. It has a parameter called weight. So I have 3 destination here, so that I have 3 individual unique number for weight. So for example, I'm going to attract this path towards central station, so that I can actually let me change the parameter, not network weight, network distance. I'm sorry. So we can shift to weight, I think. See? So this is the weight. So I'm gonna give us some custom weight, and then I'm gonna decrease the decay that the Jonghyun mentioned before. It's like decay is sort of like a far-off value than you can imagine. So once we decrease certain number, we basically attract the path because we tweak the network based on the weight, correct? And also, what if I decrease the beta value, like decay, for the Hubble sphere, and then this path in some point can attract? Come on, it's too far to affect the value. Okay, let me actually type in. I'm sorry. Okay, what happened? Still okay. So in this case, let's try. So yeah, the path is still stick to the central station, but if I increase the beta value a little bit, and then the path goes to the central station. What I mean by that is that actually, you know what? I designate the weight by manually, right? I mean, the other research question is to find the weight, you know, based on the observation that if in case that you can visit the Cambridge area and then on site like counting the individual people, yeah, and then we can tweak the weight. So sort of like a reverse engineering from the observation to the tweaking network weight. I think this is the idea behind the scene. And also we have different types of weight here. Nothing special, same as before. We have 1 origin point and then 2 destinations here. And then I give you, this is the little bit different way of giving weight. So I create a Python here. So this is the point, yeah. And then I apply decay number 0.002, and then the weight is 1000 here. So let me visualize the weight here like this. So you can play with this weight. You can minimize the weight, right? You can maximize the weight, or you can increase the decay a little bit. So meaning that the follow-up is gonna be smaller like this, okay? So this is the sort of the weight you can assign dynamically. And then what if I move this weight a little bit here? We see how it affects. A little bit. And then maybe you can move this weight to here. Because what it does is that the network is, the weight is basically tweak individual nodes weight. Yeah. So maybe the day after tomorrow, I'm gonna describe the cost function, how we calculate, how we compute the individual nodes cost. But what I'm trying to say is that this weight is basically keep tweaking the node so that throughout the backward propagation, the shortest path is gonna be a little bit different. Yeah. So this is what weight does. And then this is a little bit advanced one, but I don't know how you guys familiar with like OD metrics, which describe the connectivity about the network here. So for example, this is the simple network, right? I have an origin here, and then again, destination here. So we can get shortest path like this. Oops, yeah, shortest path like this. Do you know why? I think in my intuition, I guess this way is a more shortest path, straightforward way, but they little bit detour. This is because we assigned the connectivity. So we have built, I mean, the network analysis right now is support to the reverse way connection, but in this component help us to designate particular direction. So for example, we call it bidirected graph, by the way. So H9 is O to D, means origin to destination. And then H5 is destination to origin. Don't worry about it. This is very customized things. Based on your research purpose, we're gonna implement this idea. But I just wanted to share this idea. And then also, not only that, also I create a new edge. So node gonna be connect between 11 and 6. The way of a connection is origin to destination. So that's why we are able to get this kind of visualization, because this is one-way travel. But you know what? What if I reverse origin and destination? Yeah, I'm going to reverse so that we are able to get the straight line as a shortest path. It makes sense because this is a one-way trip, right? But on the other hand, the other direction, this edge is like a one-way trip, so we couldn't to pass it directly, so we need to detour a little bit. So this is the idea, the OD network system.
And the OD, on top of it, like OD analysis is pretty much very popular in transportation planning field as well. So this is kind of explain the very basic, and it's kind of operate okay in with our components. So yeah, if you have any kind of like one-way direction analysis or like both ways, you know, like because like now pandemic era, so like in US maybe we will provide some kind of like document later, but like in US there is kind of new regulations which about we have to walk in a park, we have to follow the one direction. So like the NJ really developed like a lot of possibilities to evaluate network system, because we want to see kind of further opportunities, you know, to merge with the COVID-19 topic as well. So yeah, yeah.
Yeah, great. So I'm also customized the Hof model that the Jonghyun already described before. We have three origin, yeah, and then 5, let's say, destination, and then individual origin has their own weight, and then destination has their own unique weight as well. And then let me see the result like this. So, okay, just focusing on the path here. Okay, if you take a look at this probability, so if you summed up all the probability, it becomes 1. 1 means like 100%. So in this case, the index number 4, because we are starting from 0, number 4 is a high probability in designated situations, 0.5, right? And then the 5th the destination is a second probability, 0.1. So we can actually visualizing the destination here. So we are starting from here, like this. So as you can see, number 3, in this case, that one's high probability. It makes sense, right? Because it is closest to our origin, right? However, as I said, we have weight here. So we can customize the weight directly. This is the like origin weight. This is number 3, right? I'm gonna decrease the weight for number 3. Oh, not this one. I'm sorry. This is correct value. Let's come back to this result. In this case, maybe the index 0 is a high probability, like 0.32. So I'm not going to dive into deeper, even if there's some component. You guys can play with it because Jonghyun already talked about it, and we have limited time here. So let me jump to other basic example. Oops. Data. So data is a basically health component to promote and facilitate your research rather than save file to jump to other application, jumping just like Grasshopper. Yeah. So here we have the describer bin, as Jonghyun mentioned before. So we have network system like this, and then we inspect the network, this network, and then the ID is in network distance, and then we get all the value like this, right? And then this is the path, and then I inserted this result to that component, and then it gives us like basic statistical result. Not only just number, but also it gives us some idea of the histogram, how we detect the outlier data, how the data is compact, which one is the, I mean, based on the data visualization, I think we need to find our strategy to deal with the post-process of the data. And then this is the little, visual idea for the decay. So let me turn on the grid here. Okay, so this is the decay what Jonghyun described before. So let's say this is number 1, right? This is a 0, right? Number 1, let's say the decays we can consider as a probability. So we have a 100 meter and then project along the x-axis, and then we get the y value. Probably this number is 0.718. This is become probability. So we're gonna multiply this number to the origin weight. So for example, we have 100 people in that origin, and then we have this much distance, and then I project for that decay, and then I got the y value. So for example, I get like a 0.65 decay. We simply multiply to the 100 people, which is weight for the origin, so that we are able to see like, oh, the probability, how many people survive in that distance, so that we can answer the question, like 65 people can survive, because according to this decay number, so we can see it. So here, if you decrease the decay, and then the probabilities become dramatically reduced. Yeah. So this is just a visualization purpose for those who are not that familiar with the decay, how it works within the network. So this is the gravity. So in order to, we have 3 different weight. One weight for the origin, the other weight for the destination, and then the last weight for the network itself. So for tweak the network weight, we use the gravity function so that we can do not only give us some like Farouk value here, but also, oops, sorry, but also the strength of the weight. Just imagine, this is just one-dimensional graph, but we can imagine how it affects throughout the network node. Yeah, I think this is a good example to understand the complex weight things. And I think this is nothing special, but I'm just creating a random point, and then we have the scatter plot like this. Because sometimes we need to visualizing the number in order to not only see the correlationship, but also see the entire picture, right? So this is the special component that I just built for you guys. Just give us some like a random number, a point based on the sigma like this. And then you can just inject the x and y to the scatter plot, and then it's automatically visualized. It's nothing special, just I populate the point. Yeah. But also sometimes we need to normalize the data, because some data is domains is like 0.21, but some is like 0.1000 of 1000 digits. So in this case, it's really hard to see. So I highly recommend you to guys to take advantage of the normalize function before visualizing. Yeah, this is the normalize. So we fit all the points between 0 to 1 along the x-axis and along the y-axis 0 to 1. Yeah, this is nothing special. And also we have a linear regression. I have two different linear regression. So one is just simple mathematication. The other one is I don't know, for you guys who are familiar with the TensorFlow. So TensorFlow has an epoch concept, right? So I'm gonna give you like 100 epoch with this data. This is the data here. And then if you unlock the timer, and then you keep fitting the designate the value. Yeah. So the idea behind the scene, the reason I implemented the gradient descent in linear regression is I'm trying to incorporate the network system with the agent-based thing. But right now, the agent is nothing because I'm still working for right now. So I'm keep thinking, based on your research question or interest, we can develop this kind of iterative optimized process between agent and network anyhow. But I prefer use this linear regression because this is quicker and simpler. So if you're familiar with the statistic and machine learning and data science a little bit, we use I-square value for the linear regression for the cost function. So number one is, we can also consider it as a probability. Yeah. So this is 1.8 I-square value here. I'm confused. Yeah. Great. So we can actually test with different types of configuration at this point. Yeah. Special. This is the other example. With this point. Yeah. Let's jump. We have a limited time. This is the last example. Okay, here. So this is nothing special, but what I'm trying to do in this example is how to hack the network in order to get the right value. So this is the example that we see before. It has a origin and destination like this, and then create the network like this, right? And then I inject this network system to this component. This is custom C# component. So, but you know what? If you want to hack this library, you need to import this library to that component. So on the right click, and there's a manage assemblies here. Click it, and then maybe add it here, and then goes to that particular folder that we install. Yeah, in the first place, there's a njs-rhino.dll. So we need to double click, and then you can move to this area. Yeah, this is just one-time operation. Once you do it, it automatically record, and then you can simply drag from here to there. That's it. And then let me open this C# code a little bit. So the first line, what I did is basically cast the NNA graph, this object as an NNA graph. This is just a syntax, so you can just follow it. And then we save this network system as a GS, and then GS has an agent. Let me quickly draw the concept behind the scene. So we have graph system here. Yeah, the graph system has origin, we call the agent. Yeah, this is the origin. And then if you inject the destination, we're gonna build graph here. Yeah. So individual, so one graph has multiple node, right? It makes sense. And then edge. Yeah. Let me quickly draw a network like this. Yeah. The graph has this node and edge, and then individual origin follow this network to compute whatever backward propagation or forward propagation. And then after we calculate all the computation, and then we duplicate the information from node and edge, and then save this data inside of the agent. So here, GS has an agent. So if you press dot like this, and then you can see agents. This is a list. And then we can do the other dot notation. Then we can see all the parameter and functions. So I can do count here. What it does is just print the length of the list. Yeah. And then I create the one for loop here. Yeah. We're gonna we're gonna select the agent by ID, which is this slider here. And then gonna visit individual node to parse the point data and then network distance data at the same time. And then I save this data inside of this list. And then I simply connect P and D in order to spit out the data, this component. So now we can see here the point data from the individual node and number. This is distance, right? So I just use this normal, component, and then visualizing false color, and then okay, then see the results like this. Yeah, this is just what I did is just visit and then ask a number or value, and then I save it, and then I export this number to this component. Yeah. Okay, we have a question. Okay. Start function. Is it possible? Start function.
Statistist. Yeah, like I saw you used some regression functions in your earlier components.
Yep.
I was just curious what kind of statistics functions you have used in.
It's very linear regression. Yeah. So you can Google it, linear regression function. This is very simple stuff. Yeah.
And like, so is it just that, or like for correlation and other stats? It's.
Yeah, I think so. Yeah. I mean, the linear regression is basically, okay, actually I can show you the code behind the scene if you want, but yeah. Hey, this is my Visual Studio code. So here you have a data, right? Okay. Okay, this is all about the linear regression equation. Yeah.
Mm-hmm.
So I sum, I pass the minimum maximum number, yeah, and then I calculate the mean number, yeah. I mean, I just follow the equation. You can Google it. There's a lot of information on the internet. It's nothing special. I'm not that like super mathematic person, so yeah.
Thanks, Namju.
You are very welcome. So yeah, this is the network, I think. Okay. Yeah. So in this component, what I did is, okay, okay, this is Cambridge. So this component is generating multiple paths between origin and destination, okay? So I create the C# component here, try to hack. So what I wanted to do in this component is just pass the ID of the node, and then get the count, how many people visit that particular node, right? So here, this is the result for the path, but I can inspect individual paths like this. Yeah. Not only that, but also we can visualizing this. Let's say this number. Yeah. I think we need to restart. Okay. Oh yeah, I think this is the ID, and then this is the number of visit. Yeah. So as you slide in the slider, you can see the number 1 is meaning that they are duplicated line. The other paths can visit, other paths previously visit this kind of node previously. So we can visualize like this. So this is how you hack the library by C# scripting. So if you guys have more question, we can actually build and hack more aggressively based on your question and research interest. Yeah, I think that this is pretty much about it. And let me quickly jump to our the slider. I mean the Medium page here. Okay, so let me show you homework. Yeah, and other let's say study material here. The homework is this is homework. Homework is more about like a basic Python stuff. Yeah, because my assumption is that we already, give you guys the components, the actual computation heavy expense operation is happening inside of the component. And then what you need to do is what kind of data we need to inject to that component and how we process the data, interpret data. So I think in that context, using the Python makes your life really easy. So if you click this code lab here, we can guide you to Code Lab. Code Lab is like an environment developed by Google, which is free, and then which is very identical as a Jupyter Notebook, which is one of the popular platform for the Python. But also you can use the GPU for free for certain hours, I guess. So this is the sort of basic Python tutorial things that you can follow. The homework is nothing special. My expectation is duplicate this one here, but don't copy paste, please. Just typing, please. This is really important. I'm sure, Don't copy paste by dragging. Yeah. So just please typing. So it. Let me quickly look the overview of this individual topic. So variable and type is very important. Particularly, we are going to dealing with the string, which is sometimes considered as a number, sometimes considered as let's say character. So in any case, you download your own custom data from local government or nationalized institution. Most of data is actually looks like string, looks like a number, but it actually is string. So we need to cast. So I think the string is really important. And then we have a number. Computer is basically calculator. So we need to understand the number. The comment is basically we just leave some message, just like a human language, nothing special. And then we revisit the string. String is basically, let's say, the list of character. So we can deal with the string as a list. Yeah. So you can index like this. Don't worry about it. I will introduce my previous YouTube video, which is English and Korean version. So I already described and make some video about this material. So I'm gonna share the link with you guys later. So I'm just quickly drop by individual topics. And then cast, as I said, The number 3 is actually, this is string, right? But we need to test as a string, cast the string to the number. Otherwise, there's no way to calculate. So number is really important. And then conditional statement. I think the computation is all about loop and condition, loop and condition, loop and condition. So this is a really important concept. So in this scope, we are going to learn, how we, the syntax of the conditional space in Python, basically. And then loop, yeah. And all the way down, we can create the multiplication table here, and then data list. I think this one is a little bit tricky, but it's really important to understand the data structure, particularly the list, because we are not dealing with one data, right? Thousands of data. So we need to take advantage of the list concept to dealing with multiple numbers here. And go down. And dictionary. Dictionary is a different types of the list. Maybe the day after tomorrow, I will drop by a little bit. But the reason I point out the dictionary is because you guys have heard that the JSON format or XML format. This is like a little bit different than the list. So particularly JSON or GeoJSON, which is popular for the GIS people. So we need to convert JSON to the dictionary in order to parse or tweak the data. Yeah. This is the dictionary. And then tuple is nothing special, just skip it. And the most important thing is the function. So there's a multiple paradigm of programming. So basically the programming is like execute line by line. We can call it like procedural programming. And this is also functional programming. So we basically group some of equation and then maintain this equation as an independent function. So whenever you need to execute the function, just simply import and then use it. Yeah, this is the beauty of the function. So I think for the data processing, we need to get familiar with how we construct function, how we tweak the function. So the function is important. Things, yeah, this is nothing special other than that. And also there's a link about Code Academy. So that you know what? When I learned Python in the very first place, I use this site a lot. Yeah, I strongly recommend you. And then Think Python. So this material is really, famous and common material for the bachelor level computer science people. So in this PDF, it talk about the Python a little bit different. It's pretty different, I think, for designer, I guess. But we can use this book as you need. You can just search it and how they describe the individual functions. I think this book is become like a 101 book for the computer science people, as far as I know. So I highly recommend you to read this book once you're familiar with the Python basic, I guess. Let's come back to here. And then also you can click this link. So I basically duplicate identical material in the what is this Colab in the Python environment. So if you guys familiar with the Python, and then you can Grasshopper. I'm sorry, Grasshopper. Just download it and then just follow the individual examples. Yeah, this is the PDF. Also, the Lino, this Lino Magnet company has their own version of the Python 101 book here. So also this is very useful for designer. I think rather than just starting from scratch, I think this book, talks about the Rhino API and geometry, which is, we are familiar with, right? So I think this book is also has a benefit for designers who familiar with the Rhino, Grasshopper, or geometry things. And then for those who can familiar with English, I guess you can click this YouTube list. This is what I did in the Digital Future workshop there. It's like a fairly extensive material. It's like a 10 hours video, at the time I was crazy because I need to work and workshop at the same time. I asked my boss 2 days vacation for this, which I never expect. Anyhow, so this is the material that talks about the Python and basic syntax. Also, there's some visualization and geometry construction that we are going to talk about the day after tomorrow. And then this is the long version of this video. Yeah, this is the long version. Maybe the first and second day, I'm going to talk about the in-depth lectures about Python. And then this is more about like a line of Python and then some visualization. I think I'm highly recommend you visit this video because it talks about how we utilize Python to visualizing data in the Grasshopper environment. I think this is a good thing for those who can speak English. And we have also the Korean version of the material. I think I can say some Korean for this. Anyhow, so this is the same material, but this is Korean version. So it made me crazy actually. I decompose individual topic. It's fairly big, index here. So you guys can visit. Particularly, I'm sorry. Here, the number in the command string casting. This is all about the Python stuff. So this is the Korean version. So Korean people can take advantage of this material rather than English version. And then this is the last link. I zip up all the material, like a Python visualization, even the image processing things, which is nothing special, but just you can extract some point out of the image in Grasshopper environment. So yeah, I mean, these are pretty much about it. I think it's time to have Q&A time and discussion, I guess. That's it.
Yeah, and before doing that, like we just briefly talk about tomorrow's schedule. Actually, yeah.
Thank you. Yeah, so. Yeah, so for those who are in Unit 2, tomorrow, 9 a.m. in Korean time, we're gonna have a meeting. So in that meeting, we're gonna talk about how we make a team. And if you guys have any question while doing homework or explore the NNA tool, we're gonna have a troubleshooting time. And this is like a regular daily based regular meeting to push you guys to do something.
Yeah, this is like extra hours, like kind of prep, like which is like you spend more time to prepare for the second week. So yeah, you can do kind of like brainstorming for your research questions and or exercise with NNA2 and exercise with Python materials, because of course it's kind of even for me, the computer language is not very familiar yet, so I will study during this time as well. So because I realized that NJ and I developed the NNA tool, and at least if I very understand or use well with the Python, actually there are lots of like varieties you can use it like kind of much better ways. So yeah, hopefully you guys can digest NNA2 and Python like at the same time. So yeah, we try to help you out to push to your boundaries. Of course, it will be very tough, but if you want to, we can help out. So yeah, we have daily we have daily 1 hour kind of discrete and discussion time. 9 in the morning Korean time, so please join. Yeah, and we have a Q&A session maybe.
Any questions or any feedback? I know personally, to me, it was a little bit fast.
Okay. That's why we have daily meeting.
Yeah, we have daily meetings, so like, yeah, we invite like unit 2 students, but like if you have a very specific questions about our tool or the materials from NJ, yeah, we just welcome everybody, yeah, for this prep time.
Hi, I have a question.
Yes.
Yeah, sure. Yeah.
Just regarding the network again. So sometimes we prefer to use certain part, you know, because that part actually have some kind of like a interesting, I don't know, like stores or something like that. Can we take that account in the in that study or not?
Also, like maybe I'm missing some part of your question. So what do you want to count for the network analysis?
So like the part like the streets usually they're not the same. You know, like some streets actually a bit more interesting than other streets. You know, like streets with more shops or I don't know, like usually major street people usually go to the major street first, then taking the small alley, something like that. I don't know, should we take account of that as well when we do this kind of study?
Yeah, sure. Yeah, sure. It's possible because like how you are giving the weight for the network is sorry. So how to giving the weight for the network is it's actually the solution. So, but you have to think about how to measure it. For example, the narrow alley is maybe better than like wider kind of road. So you have to have like the data about the width of the street, and then you can give that data as the network weight. Like maybe narrow width is more attractive than the wider one. So it really depends on how you define your weight for the network or for the origin or for the destination. But the key thing is that how you measure it, you how to collect this weight data as well. So because like of course like we can do kind of little bit about like more artistic kind of approach based on our intuitions or hypothesis, but if you really want to apply it to your real actual project, you need a very clear data or which you can use it for your actual project. But it sounds possible. Yeah.
Okay, thank you.
From my perspective, as I said, we have a multiple step to build the analysis. The first step is to create a network line. Yeah, so maybe in that stage we can explicitly, draw the small alley or whatever network that you want to take into consideration. And then while we back propagate, we can also assign some weight that you can, otherwise you can just visit and then count some data, or you can download from the city. I don't know. So we can weight the network, and then you have your own hypothesis, right? So we can just make some scenario or some like the action sequences, like a procedure to prove your the network analysis system. I think it's more about like how we build the environment of a network, I guess. Yeah.
Yeah, thank you.
Any other question? Because we are super great to teach, so you guys totally understand everything. Otherwise, we are like really bad at teaching, so you guys have no idea what's going on, right? Or,
I think I just need some time to digest all the information.
yes, please. Yeah.
Yeah,
Sure.
it was pretty intensive though, and also I'm pretty sure that there are some people who are not familiar with all this coding and Python everything. So maybe some of us need time to revise everything.
Yeah.
And
So I don't know whether you guys remember or not. Yesterday, the slide, I have three like a keyword, right? The first keyword is understanding network analysis system. What I mean by that is that NJ&Woo already teaches us like how we evaluate the number, right? Because we already pre-cooked all the components that we particularly analysis that section like centrality and accessibility. I think understanding that one is really super important. And the second thing is that compose, assemble or disassemble the NNA tool based on your interest. I think this is also important. And then the last one, I think that the last layer is learning Python, I guess, when considering the time, because we have only 2 weeks, right? So, but for those who are in Unit 2, we also consider like a post, production things. So I highly recommend the people, bring the research topic or interest. I think this is more important, I guess. And then on top of it, I will take a look at this project from my perspective as a technical, like what kind of component, what kind of the statistical, the computation need. And then also NJ&Woo, she gonna, bring more like a idea from her, like a perspective, and then we can build step by step. If they need learning Python, we can spend our time to, learn the Python. Yeah, just like this. So I think, let's say like project-oriented learning workshop. Yeah.
Yeah, so I think like of course like in second week we already collected the data from Seoul, so our research site will be Seoul because we can provide data. But if you wanna research about like other cities or other location, it's still very open to test. So bring your own interest, because like if you have your own interest, you can you have a kind of strong motivation, right, to learn about and to exercise about the tool. So and yeah, again, the Python will be very helpful in the end. Like maybe this time you learn about NNA tool and things, but you will definitely have feeling that Python will help a lot, to develop further using NNA tool, and also for your future research as well. So we try to make kind of very nice, kind of big forest kind of like pictures for you. But I know it's kind of lots of things are going on in our materials. So try to digest as much as you can. But we are kind of very open to everybody. So and also we will keep continuing this research after this workshop, and we are interested in produce like small or peer-reviewed journal papers as well. So if you, one of you, some of you are interested in like writing or in any kind of field, just contact us and then we can work together as well, even after this workshop. So yeah, just for us it's the first day, so just to start to think about your own interests and something related with network analysis. And just if you just have a brilliant idea or interesting idea about this, just share with us and we can talk about it.
Thank you very much. I think for me also the best way of learning tool is to do something goal-oriented. Like if you have a very strong goal and try to learn things to achieve that, then you don't really have to learn everything. You only need to learn the tools that you need to achieve to that goal. So I think this is a very good exercise for everybody.
also try to make it something your own. by doing your own projects from your own idea, probably next week. That would be ideal, I think.
Great. Yeah. Thank you very much for two tutors who spent a lot of effort preparing. I know they were preparing this for a long time with like really extensive time and effort. Thank you so much. We really look forward to the outcome from this workshop. And I hope everybody enjoyed.
Thank you.
Thank you.
Thank
Thank you.
Yeah.
Wrap up this meeting. Thank you.
you. Bye.
I'll see you guys in 3.5 hours.
Bye.
Great. Bye.
Bye-bye.
Bye.
Bye.